Welcome to another deep dive. We're going to be talking all about databases today.
Ooh, databases.
You guys want to know how they work, right?
Absolutely.
So we're diving into this classic textbook
Classic.
called Database System Concepts.
Love it.
And, you might not even realize it,
Right?
but you use databases every single day.
Oh, yeah, absolutely.
Every time you shop online, book a flight,
All the time.
check your social media,
Behind the scenes.
there's a database quietly working away.
Oh, it's crazy.
So where do we even begin with something this big?
Well, the textbook starts with, a really simple definition.
Okay.
A database is just an organized collection of data, usually stored and accessed electronically.
So it's like a
Like
digital filing cabinet.
Yeah, like a super organized one.
Okay, but what makes it different from just having a ton of files on my computer?
It's all about, the organized part.
Oh,
The databases aren't just, random piles of information. It's structured in a way that makes the data, really easy to search and analyze and update.
so it's like the difference between having a well-organized library with a card catalog
Yeah.
versus a room full of just scattered papers.
Perfect analogy.
Okay.
And just like a library can have books on a ton of different subjects, databases are used for such a wide range of applications.
Oh, for sure.
Like the textbook mentions universities using them to store student info,
Oh, yeah.
airlines for reservations, flight schedules,
Makes sense.
banks using them for financial transactions.
Wow, so much data.
It is a lot of data.
So how do they keep all this information organized in a way that actually makes sense?
That's where the relational model comes in.
What?
It's the most common way to organize databases.
Okay.
It's all about tables, not spreadsheets.
Wait, hold on.
Yeah.
Tables?
Yeah.
What's the difference?
So, think of it this way.
Come.
A spreadsheet, it's great for calculations, simple lists.
Yeah, I use spreadsheets all the time.
Yeah, totally. But a table in a database, it's designed for storing structured information about specific things.
Oh, okay.
Each row in the table represents one unique thing,
Okay,
like a student, a book.
got it.
And each column represents a specific attribute of that thing, like their name, address, or ID number.
So if we had a table for students, each row would be a different student.
Yep.
And the columns would be things like their name and their GPA.
Exactly. And the textbook actually uses a great example of a table called instructor
Okay,
to show this.
makes sense.
Each row represents a different instructor at a university.
Okay.
And then the columns includes things like their ID, their name, department, salary, all that.
But how do we make sure that each row is unique?
Good question.
What if we accidentally had two instructors with the same information?
That's where primary keys come in.
Primary keys.
Yeah, they're like a unique ID card for each row in the table.
Okay.
Think of it like a social security number. No two people have the same one.
Right, makes sense.
In our instructor table, the instructor's ID would be the primary key.
So we can always tell them apart.
Exactly, ensuring that we can always identify each instructor uniquely.
It's like a digital fingerprint for each entry.
You got it.
But how do we actually get information in and out of these tables?
Good question.
We need a way to communicate with a database, right?
You got it, and that's where SQL comes in.
SQL.
Yeah, it's the language of databases.
Okay.
SQL lets us define the structure of the database, create tables, and then do all sorts of things with the data.
Like what?
Like adding new information, updating existing entries, retrieving specific data we need.
So it's like a programming language, but just for databases.
Exactly. And it might sound a little intimidating at first,
Yeah, a little bit.
but SQL is actually pretty intuitive.
Oh, okay.
Uses commands like select, from, and where.
Yeah. Okay.
Those are pretty close to how we talk in everyday language.
Right. So I could say something like, select name from instructor where salary is greater than $85,000.
Exactly. You got it.
And the database would be like, okay, I know what you're looking for.
It's like having a conversation with the database,
So that's cool.
telling it exactly what information you need.
Okay.
And SQL is really powerful. It can do way more than just simple searches.
Oh, wow.
It can handle complex calculations, it can sort data, and even combine information from multiple tables.
That's impressive.
It is pretty cool.
But we also need to make sure that the data in the database stays accurate, right?
Oh, absolutely.
Consistent.
Yes.
What happens if someone enters the wrong information
Oh, yeah.
or tries to add duplicate entries?
Right. That's where data integrity and constraints come in.
Data integrity, okay.
Think of constraints like rules that the database enforces
Okay.
to make sure that data stays clean and reliable.
Okay, so it's like a safety net
Exactly.
to prevent us from making silly mistakes or like
Yeah.
accidentally corrupting the data.
You got it. And one of the most important types of constraints is called a referential integrity constraint.
Referential integrity.
Yeah, it's not as bad as it sounds.
Hopefully not.
Let's go back to our instructor table example.
Oh.
Each instructor belongs to a specific department, right?
Right.
So with a referential integrity constraint, we can make sure that every instructor in the database is linked to an existing department.
So we can't have like an instructor floating around without a department.
Exactly.
That makes sense.
It's like making sure every book in the library has a proper shelf location.
Perfect analogy.
Referential integrity helps us maintain those logical relationships.
Between different parts of the data.
Yeah, making sure the database makes sense as a whole.
Okay, so databases are all about organizing information logically
Yeah,
and making sure it stays accurate.
absolutely.
But I have a feeling there's a lot more to it
Oh, there's so much more.
and meets the eye.
We haven't even touched on one of the trickiest concepts, the null value.
The null value.
Yeah.
Okay, this sounds scary.
It's a little bit of a headache sometimes.
Oh.
So sometimes we don't have all the information for every entry in a table.
Okay.
For example, not every instructor might have a phone number listed.
Right?
So what do we put in that field? We can't just leave it blank.
Right.
That's where the null value comes in.
The null value.
It represents missing or unknown information.
So it's like a placeholder
Kind of.
for information that's not available yet.
Right.
But why is that such a big deal?
Well, it turns out null values can be a real pain for database designers and developers.
Oh, no.
They don't behave like normal values.
Oh, okay.
And they can cause all sorts of issues when we're trying to, analyze or manipulate the data.
What kind of trouble can they cause?
Well, for starters, they can really mess with calculations.
Oh, no.
Imagine we're trying to calculate the average salary for all instructors, right?
Right.
What happens if some instructors have a null value for their salary? Do we include them or not?
Yo, yeah.
It gets messy.
It's like a missing piece of a puzzle
Exactly.
that throws off the whole picture.
And that's just the tip of the iceberg when it comes to null values.
Uh-oh.
We're going to have to dive a bit deeper into that rabbit hole later.
I have a feeling things are about to get interesting.
Oh, yeah.
Okay, so we've talked about tables and primary keys.
Right.
SQL.
Yes.
And even that scary null value.
Right.
Feels like we're building like a whole mental model.
We are.
How databases work.
Totally.
To like really solidify that model, we need to talk about database schemas.
Oh, yeah. Schemas are key.
Is that like a blueprint
It is. It's a great way to put it.
of the database?
It's like an architect's blueprint for a building.
Okay.
It defines the structure of the database.
Okay.
Lays out all the tables, the columns,
Yeah.
how they relate to each other.
Okay.
The textbook actually gives a full schema for a university database as an example.
Oh, cool.
Yeah, it's really helpful to visualize it.
So it's not just throwing tables together like randomly.
Yeah, no.
There's some serious planning involved.
Absolutely. A well-designed schema is crucial
Okay.
for efficiency, data integrity.
Yeah, that makes sense.
One of the key goals is to minimize redundancy.
Redundancy, okay.
Which basically means avoiding storing the same information in multiple places.
Right. I can see how that'd be a problem.
Yeah.
Imagine if every time we entered a new student,
Right.
we had to also type in all the details about their major, like the department, office
Or
location,
the course list.
everything.
Oh, it'd be a nightmare.
That would be a nightmare.
To keep updated.
Exactly.
That's why we use relationships between tables.
Okay.
So instead of repeating all that information in the student table, we can just link each student to their major using a foreign key.
Foreign key, okay.
That way, if the major's details change, we only have to update them in one place in the major table.
So it's like each table is a piece of a puzzle, and the schema shows us how they all fit together.
Perfect. Yeah, love that analogy.
To make sure those pieces fit together correctly, we need to understand functional dependencies.
Ah, yes. Functional dependencies.
There come the technical terms.
I know, but it's not as complicated as it sounds.
Okay, good.
Functional dependency just means one piece of information in a table determines another piece of information.
Okay.
For example, in our instructor table.
Right.
If we know the instructor's ID, we automatically know their name.
Right, because the ID
Yes.
uniquely identifies each instructor.
There can only be one name associated with that ID.
Yeah.
So we say that the instructor's ID functionally determines their name.
Okay.
And understanding these dependencies helps us design better schemas,
Okay.
eliminate redundancy, and prevent all sorts of data inconsistencies.
So functional dependency is like a rule.
It is a rule, yeah.
If you know this,
Yeah.
then you automatically know that
Exactly.
it's all about the relationships
Right.
between different pieces of information.
You got it. It's a little bit like detective work,
Oh, yeah.
figuring out the hidden connections within the data.
Yeah.
And it leads us to this really important process called database normalization.
Normalization, does that mean like
Yeah.
making everything fit a standard format?
Kind of like that, yeah.
Okay.
It's a set of guidelines for organizing data in a way that minimizes redundancy
Okay.
and ensures data integrity.
Right.
It helps us avoid weird anomalies.
Anomalies like what?
Okay, so imagine we had a table
Yeah.
that listed students and their majors and the advisor for each major.
Okay.
If we weren't careful,
Yeah.
we could end up in a situation where we delete a student but accidentally also delete their advisor's information
Oh,
because it was only stored in that one row.
yikes, that sounds bad.
It is bad, yeah. It's a recipe for disaster.
Yeah.
Normalization helps us avoid those kinds of problems by breaking down large tables into smaller, more focused ones.
Right. And defining clear relationships between them.
Okay, so it's like
Yeah.
organizing your files into folders and subfolders.
Exactly. To keep everything tidy and accessible.
A little spring cleaning.
I like that spring cleaning for our database schemas.
Yeah.
There are different levels of normalization,
Okay.
each with its own set of rules and benefits.
Gotcha.
The textbook focuses on two key forms,
Okay.
BCNF and 3NF.
BCNF and 3NF, those sound like secret codes.
They kind of are, yeah, secret database codes.
Okay.
So BCNF stands for Boyce Codd Normal Form,
Okay.
which is the strictest form of normalization. It's like
Whoa.
the gold standard.
Yeah.
But it can be difficult to achieve in practice.
Okay.
3NF, or Third Normal Form, is a bit more relaxed.
Okay.
Offers a good balance between eliminating redundancy and maintaining flexibility in the design.
So it's like a trade-off
Yeah.
between being like super organized
Yeah,
and being practical.
exactly.
The right level of normalization really depends on the specific needs of the database
Right.
and the applications that will use it.
Okay.
Sometimes a little bit of redundancy is acceptable
Okay.
if it improves performance.
Right. So it's not just about following the rules
Yeah.
blindly.
We need to consider the big picture.
Okay.
Make smart decisions based on the specific situation.
Database design is all about balancing, like
It is, yeah.
competing priorities.
Absolutely.
Normalization played a key role in that whole process.
A key role, for sure.
But at the end of the day,
Yeah.
the goal is to create a database that's both efficient and reliable.
Right.
A solid foundation for storing and managing information.
Absolutely.
This is all fascinating.
Yeah, it is pretty cool.
But my brain is starting to feel a bit full.
I know. It's a lot to take in.
We've covered a lot of ground,
We have.
from the basic definition of a database to
Yeah.
schemas,
Right.
functional dependencies,
Uh-huh.
and normalization.
Yeah. You've done a great job keeping up. We've laid a really solid foundation,
Okay.
but there's still so much more to explore.
Oh, there is.
Yeah.
Okay.
Next, we'll dive into the heart of SQL.
Ooh, okay.
Uncover the magic of queries, the tools that let us actually extract meaningful insights.
Okay, from all this organized data.
Exactly. That's where the real fun begins.
Okay, I'm ready to unlock the power of SQL queries.
It's like we've learned the layout of the library.
Right.
And now we're getting our library cards.
Exactly.
We can finally check out some books.
SQL queries are how we communicate with the database, right?
Exactly, yeah.
We can tell it what info we need.
We're asking it questions
Okay.
to get specific insights.
The textbook jumps right into some examples,
Oh, yeah.
showing how we can use commands like select,
Right.
from, and where
To retrieve specific data.
from tables.
Yeah. It's a little like solving a puzzle,
Ooh, fun!
figuring out how to piece those commands together.
To get the exact information we want.
You got it.
SQL gives us all these operators and functions.
Yeah, it's like a detective's toolkit.
Ooh.
We can use comparison operators.
Okay.
Like greater than, less than.
Define values within a specific range.
Exactly.
So if we wanted to find all instructors earning over $100,000,
Yeah.
we could use the greater than operator in the where clause.
You got it in the where clause.
Okay, cool.
And what if we were looking for instructors whose last names start with S?
Ooh, okay.
We can use the like operator with a wildcard.
To find all the names.
Yeah, all the names that match that pattern.
It's like a super-powered search engine.
It is. It's a search engine just for our database.
For our database, that's so cool.
What if we don't want individual records, though?
Okay.
What if we want to see the big picture?
Oh, okay.
Like the average salary for all instructors.
Or the total number of students in each department.
Exactly.
Okay.
SQL has got us covered there, too.
Okay.
It provides aggregate functions.
Aggregate function.
Yeah, things like AVG, count tool, and SESM.
Yeah.
Let us perform calculations on entire sets of data.
Ooh, that sounds powerful.
And we can even group data.
Okay.
Based on specific criteria.
Using
The groupie by Y clause.
GRUPBY. Okay.
Yeah, so we could group all instructors by department.
Right.
And then use the AVG function to see the average salary for each department.
Okay, so we can create like customized reports.
Exactly.
Highlighting the key metrics and trends that we need.
You got it. You're getting it.
But what about those situations where we need information from multiple tables?
Good question.
How do we connect the dots between different parts of the database?
That's where the magic of joins comes in.
Joins. Right.
SQL's join clause lets us combine data from multiple tables.
Based on.
Shared attributes, it's like taking pieces of different puzzles.
Okay.
And finding the edges that match.
Oh, okay.
So we can create a more complete picture.
So if we wanted to see the names of instructors along with the titles of the courses they teach, we could use a join to link the instructor table and the course table.
Exactly. We would join them based on a common attribute.
Like the instructor ID.
Like instructor ID, exactly, which exists in both tables.
Oh, okay. So that we can see how different parts of the data are related.
Precisely.
I can't help but wonder how the database actually processes all these queries.
Yeah, it's a good question.
Does it just follow the steps that we write?
That's where it gets really interesting.
Okay.
Databases have these things called query optimizers.
Query optimizers?
Yeah, they analyze our SQL code.
Oh, wow.
And figure out the most efficient way to execute it.
So it's not just blindly following instructions.
No, it's actually being smart.
Oh, okay.
About how it retrieves the data.
It's like finding the best route on a map.
Exactly. Perfect analogy.
Some routes might be faster or less congested than others.
The query optimizer wants to find the optimal path.
To get the info we need.
Exactly.
It's like a super smart assistant.
It is. It's working behind the scenes.
To make sure our queries run as fast as possible.
As efficiently as possible. That's right.
Query optimization sounds like a constantly evolving field.
It is, yeah. As databases grow larger,
right.
more complex, researchers are coming up with new ways.
To make them even better.
To squeeze every ounce of performance out of them.
Oh, okay.
It's pretty cool.
This has been a really cool deep dive.
It has been. We've covered a lot.
We started with the basic definition of a database.
Right.
And we ended up exploring SQL queries.
Yep.
And query optimization.
You've been a great student. I'm impressed.
Thanks. I definitely have a deeper appreciation now.
That's good.
For this whole world of data management.
It's a fascinating world.
That powers so much of what we do online.
Absolutely. It's everywhere.
Now, every time I use a website or an app, I'm going to be thinking about all the clever database systems working behind the scenes.
That's the spirit. That's what I like to hear.
This is just the tip of the iceberg, though, right?
It is. The world of databases is vast.
And always evolving.
Always changing. Always something new to learn.
Thanks for taking us on this journey.
It's been my pleasure.
Into the heart of databases.
To our listener, keep exploring. Keep asking those questions.
Yeah. Who knows? Maybe someday you'll be designing the next generation of revolutionary database systems.
The possibilities are endless.
Thanks for joining us on the deep dive.
It's been fun.
We'll catch you next time.